All right, we've looked at even and odd functions before, and we're going to look at trig functions with the same properties of either being even or odd. Uh, the idea is exactly the same as we had before. Of course, now it's just applied to trig functions instead. So what does it mean for a trig function to be considered to be even? It means that the output of the trig function when the angle is negative is equal to the output of the trig function when the angle is positive. And the only two functions, trig functions, that are considered to be even that have this property are going to be cosine and the reciprocal of cosine, which is secant. So let's take a look, at why that's the case. Why is cosine and secant considered to be even? So we're going to maybe look at a visual of this property. So, here we're looking at a unit circle, and you can see here we have a positive angle. And so what is the cosine of the positive angle? What is the value of x for that positive angle? Well, the value of x is this distance right here. All right, now let's look at the negative angle. So if we have a negative angle, so maybe this one was positive 30 degrees, this one would be negative 30 degrees. So what's the cosine of this negative angle? The cosine of this negative angle is this x value right here. And what you can see is that the x value for cosine of the positive angle is equal to the cosine of the negative angle. They're the exact same length, and they're the exact same positive x value. Okay, so cosine of a negative angle, so the cosine of negative 30 is equal to the cosine of positive 30. They have the same x value. They're both positive in this case. If the angles had both been positive, but they'd been over here in quadrant 2, like that, well, guess what? The x values of these two would be exactly the same x value, but they would just both be negative. Okay? So that's why cosine is even. Cosine will give you the same output value if you've got a negative or a positive of that same angle measure. And when we come down here and look at secant, right? So the secant is the length from the origin out to where the tangent line intersects the x-axis. That's the length of the secant. And so you can see that if we have the secant of a positive angle, it's this positive value. And if we have the secant of the negative of that angle, we're going to have that same positive value. So both of these are the same positive value, regardless of whether it's a positive angle or a negative angle. The secant of both is the same. So the secant, the output of secant of a negative angle is equal to the output of the secant of a positive angle. It's the same. So that's why cosine and secant are both considered to be even. Now, let's use this same test, but let's use it for sine, for example. Okay, so here's sine, and here we have a positive angle, and here we have a negative angle. Oops. Just like we just did with cosine. Well, if we take the sine of a positive angle, we get this value, which is going to be a positive y value. But if we take the sine of a negative angle, we end up with a negative y value. So you can see if we take the sine of a negative angle, we get a negative y value. And if we take the sine of the positive version, we get a positive y. Let me use same colors here. And those are clearly not equal to each other. So that means that sine theta is not even. Okay. Well, if it's not even, could it be odd? And you see the one distinction between odd and even is that they're pretty much all the same, right? The output of a negative angle, the output of a positive angle, but for it to be odd, you can put an extra negative right out there in front. So if you have the negative of the output of a positive angle, sorry, the negative of the output of a positive angle, and it's equal to the output of the negative angle, then it's considered to be odd. So if we come down here, and if we put a negative out in front, well, does negative y equal negative y? It does. So the sine of a negative angle does equal the negative sine of a positive angle. So that is what makes, sorry, my computer isn't keeping up. That's what makes this an odd function, is that this property here is true. This property up here ended up being false. And, kind of understanding this part of it, can be a little abstract, which is why I like this visual down below. You can see here that the cosine of the positive angle and the negative angle were both the same. But here you can see the sine of the positive angle is this, it's a positive number, and the sine of the negative angle is a negative number. They're not the same. So when you see something like this, then you know it's going to be odd. Now let's look at tangent. So when you have a positive angle like this, and you've got that line tangent to it, the tangent value is this value here. And this value will be different from that one. They're not kind of overlapping each other like they were with cosine and secant. And so the same will also be true of the reciprocals. So, if sine is odd, then its reciprocal will also be odd. Since tangent is odd, the reciprocal of tangent, which is cotangent, that'll also be odd. Okay. That's it for kind of describing, odd and even trig functions. Let me know if you have any questions.